This video will cover the first third of Chapter 5 about gases, from Section 5.1 to 5.3. Gases are one of three physical states of matter, and while few substances exist as gases, gases are important. First, let's talk about Section 5.1, pressure. A barometer is a device that measures atmospheric pressure. Atmospheric pressure comes from the mass of air being pulled towards Earth by gravity. Atmospheric pressure changes with altitude and weather conditions. The most commonly used units for pressure are millimeters of mercury and torr. Please note that 1 standard atmosphere equals 1 atm, which equals 760 millimeters of mercury, which equals 760 torr. Pressure is force per unit area, so the unit of pressure in the SI system uses the Pascal. Based off of the Pascal, 1 standard atmosphere is 101,325 Pascal. Now, let's do a problem involving pressure conversions. If the pressure of a gas is measured to be 46 torr, how many atm and Pascal is this? So 46 torr and 1 atm is 760 torr. Cancel units and multiply to get 0.061 atm. Now you take 0.061 atm and you do the unit conversion of 1 atm equals 101,325 Pascal, and that equals 6,200 Pascal. Now let's move on to Section 5.2, the gas laws of Boyle, Charles, and Avogadro. Firstly, Boyle's law studies the inverse relationship between pressure and volume. The formula is P1V1 equals P2V2. Here's an example problem using Boyle's law. Consider a 4.60 liter sample of carbon dioxide gas at a pressure of 6.40 times 10 to the 3 Pascal. If the pressure is changed to 6.80 times 10 to the 4 Pascal at a constant temperature, what will be the new volume of the CO2 gas? So the formula P1V1 equals P2V2, and you'll just plug in the numbers given. So you'll set 6.40 times 10 to the 3 Pascal, multiply by 4.60 liters, and you'll set it equal to 6.80 times 10 to the 4 Pascal, multiplied by V2, which is what you're trying to find. And plug it into the calculator, and you'll get V2 equals 0.433 liters. Here's a sample problem using Charles's law. A sample of gas at 22 degrees Celsius and 1 atm has a volume of 4.60 liters. What volume will the gas occupy at 32 degrees Celsius and 1 atm? So you write down the formula V1 over T1 equals V2 over T2, and then you just plug in the numbers. V1 equals 4.6 liters over T1, which is 22 degrees Celsius plus 273 Kelvin. You set it equal to V2, which is what you're trying to find, over 32 degrees Celsius plus 273 Kelvin. And you plug it into the calculator, and you find that V2 equals 4.76 liters. Third, Avogadro's law observes that equal amounts of gases at the same temperature and pressure contain an equal number of particles. The formula is V equals AN, where V is volume of gas, N is number of moles of gas particles, and A is just a constant. Here's an example problem using Avogadro's law. Suppose we have 14.6 liter sample of 0.600 moles C2 at a pressure of 1 atm and temperature of 25 degrees Celsius. If all of the C2 gas will convert it to C4 gas with the same temperature and pressure, what would be the volume of the C4 gas? So first you want to balance the equation. So you'll get 8 C2 gas to 2 C4 gas. And then you'll find the moles of C4 gas in the end, which you'll do 0.60 moles of C2 times the unit conversion of 2 moles of C4 over 8 moles of C2, which gets you 0.15 moles of C4. Then you plug it into the equation. V1 over N1 equals V2 over N2, which gets you 14.6 liters of C2 over 0.600 moles of C2 equals V2, which is what you're trying to find, over 0.15 moles of C4. And after you plug it into the calculator, you'll find that V2 equals 3.65 liters. Moving on to section 5.3, the ideal gas law is an equation for calculating the state of a gas. The formula is PV equals nRT, where R is a constant with the value 0.08206 liters of ATM over moles per Kelvin. A certain state of gas is illustrated through pressure, volume, temperature, and number of moles. Knowing only 3 of the 4 properties listed is enough to define the state of gas, because the last property can be found through the ideal gas law equation. Please note that the ideal gas law is empirical, meaning it is based on experimental measurements of the properties of gases. Thus, such gases behave under hypothetical ideal conditions, with gases at low pressures and high temperatures. Here's an example problem using the ideal gas law. A sample of helium gas has a volume of 4.68 liters at a temperature of 273 Kelvin and a pressure of 0.86 atm. Calculate the moles of He2 molecules present in the sample of gas. So the equation is PV equals nRT, and you're trying to solve for the moles of gas. So you set N equals PV over RT, and then you plug in the numbers. P equals 0.86 atm, V equals 4.68 liters, R is the constant 0.08206 liters atm over moles of Kelvin, and T is 273 Kelvin. Then you plug it into the calculator and you get 0.180 moles. This concludes the first third of Chapter 5 from Section 5.1 to 5.3.